In this video lecture, I will discuss Turing machine. So what is Turing machine? Turing machine is modified version of push down automata and it is much more powerful than PDA. So we can say it is more powerful than push down automata, and push down automata we use this concept of stack. Turing machine uses the tape to store the symbol. So tape is used to store the symbol, and the Turing machine is a generalized machine which can recognize all types of languages. That is regular language, that is generated from regular grammar, or we also call it type 3 grammar, and context free languages CFL, that is generated from context free grammar, or also known as type 2 grammar, and context sensitive language, that is generated from context sensitive grammar, or we also call it type 1 grammar. So apart from these languages, the Turing machine also accepts the language generated from type 0 grammar. Okay, so type 0 grammar, that is also known as unrestricted grammar. So thus we can say the Turing machine can accept any language. Okay, so the same thing is explained here, a very powerful, or we can say abstract machine that could simulate any modern day computer. So Turing machine, why to design such machine? There are some problems which cannot be solved even using a Turing machine. Then it implies that the problem is undecidable. Okay, so in Turing machine we have basically three components. We can say it has three components: tape, read write head, and control unit. Okay, so you can see here this tape is nothing but it is like a memory. Okay, so first there are three components of Turing machine: tape, read write head, and control. Control unit is nothing but this finite control shown here, and this is nothing but we can say it is read write head. So it has three components. Now what is tape? This tape is used to store the information and is divided into cells, you can see here, and each cell can store the information of only one symbol, and the string to be scanned will be stored from the leftmost position on the tape, and the string to be scanned should end with blank. So here you can see blank, and the tape is assumed to be infinite both on left hand side and right hand side of the string. So from both the side, left and right side, it will be infinite. And read write head, the read write head can read a symbol from where it is pointing to and can write into the tape to where it points to. And this control unit, or also it is also called as finite control, this is used to read from the tape or write into the tape, and it is determined by the control unit, and the different moves performed by the machine depends on the current scanned symbol and the current state, and the control unit consults action table, that is also called as transition table, and carry out the task. So this read write head can move either in the left direction or it can move towards the right direction. That is, movement can be on both the direction. So the various actions performed by the Turing machines are changing the state from one state to another state. So changing state from one state to another. So these are all action performed by the Turing machine. And then the symbol pointing to by the read write head can be replaced by another symbol. So symbol can be replaced by another symbol, and the read write head may move either towards left or towards right direction. So movement towards left or right. So left we will show by L and right we will show by R. So if there is no entry in the table for the current combination of the symbol and the state, then the machine will halt. And the Turing machine can be represented using various notations: transition table, instantaneous description, and transition diagram. So there are three ways to represent a Turing machine: transition table. We have also seen this in PDA and finite automata, and instantaneous description, or also called as ID, and transition diagram. So these are the three ways to represent a Turing machine. So you can see here infinite tape with tape symbols. This x1, x2, x3, xi, xn, these are input and output tape symbols, and the tape will be infinite from both the end. So this 3 dot is used to represent the infinite tape. Now what is transition function? So here transition, the movement is denoted by this symbol, and Turing machine does the following thing. So we have seen the transition function for finite automata and push down automata. So here in Turing machine we will be having some current state, same as so you can see here this transition function, it is taking two parameter, where q is the current state and this x is the current tape symbol pointed by the tape head, and then from q machine is changing its state from q to p, and then after the move what is happening, this x is replaced by the symbol y, and this d is indicating the direction, so it can be left or right. So if d is equal to L, the tape head moves towards left by one position. Alternatively, if I say d is equal to R, the tape head moves right by one position. So the same thing, this is the transition function, and for the same transition function this is the graph representation. So you can see here we have q as a current state and p as a next state. So two states are shown, q and p, and when we read input x, so this x is nothing but the current tape symbol, because input will be stored in the tape. So when the current tape symbol is x, what is happening, x is replaced by y, so we have to put slash, and then this x is replaced by y, and here in place of d we have to either write L or R. So for example, if I say delta q naught a, okay, and here we write q1 x and r. So the meaning is the machine is in state q naught, okay, the current state of the machine is q naught, and the next state of the machine is q1, okay, and when I read input a, and this a is nothing but the current tape symbol, what is happening, a is replaced by x and the read write head move towards right direction, okay. Or if we say delta, suppose we say delta q2y is equal to q2y L. So here the current state and next state is q2, and the current tape symbol is y, and y remains y only, and read write head will move towards left direction. So this will be represented by the state q2, and there will be self loop because the machine is not changing its state. We read y, and y will be replaced by y only, and machine will, the read write head will move towards left direction. So if we have a transition function, so there will be two parameter, and here we'll have 3, and for the transition function, this is how we write the transition graph. Okay, so in the previous slide there were some basic definition of Turing machine. There were some tuples defined here. So we have already seen machine definition, finite automata and pushed on automata, this Q, sigma and delta and F, and even Q naught. So this will remain same. This capital Q will be nothing but the set of state, sigma will be the set of input alphabets, and delta will be the transition function, and Q naught is the start state, and F is the final state. So all these tuples will remain same, but here we have two additional thing. This symbol, this is nothing but, this is called as the tape symbol. So this is a, we can say this is a set of tape symbol, and this B we have seen here, this is blank symbol. So this B is a spatial symbol, we will say it is a spatial symbol indicating blank character. Okay, indicating blank character. And here delta function, this is very important, delta function will be, will say a delta will be a transition from Q into this tape symbol to Q to tape symbol to left or right. So how we have written this? So you can see the first parameter of the transition function in Turing machine, it is some state. So that is going to come from capital Q. And the second parameter we say it is a tape symbol. So tape symbol is here represented by this symbol. And then here we get some state. So that also is going to come from capital Q. And the second parameter is again a tape symbol. So that will be this capital, this will be the tape symbol, and then the third one is nothing but the movement. So left, it will be either left or right. So this will be the transition function for the Turing machine. So these are all tuples of the Turing machine, Q, sigma, and this is used to represent the tape symbol. Delta is a transition function, which is this one, and then we have some start state, we have a special character indicating the blank, special symbol indicating the blank character, and then F is a final state. So hope the definition of Turing machine is clear and the basic concept is clear. Thank you for watching.